Alright, what's up guys? It's Matt back with another math video. Today we have a tricky one. This is the 2020 AIME problem number 2. So, there is a unique positive real number x such that three numbers log base 8 of 2x, log base 4x, and log base 2x in that order form a geometric progression with a positive common ratio. The number x can be written as m over n, where m and n are relatively prime positive integers. Find m plus n. So a lot going on in this problem. First, we see that it's a geometric progression, which means that the ratio stays constant and it's positive, so it's not going to flip back and forth between negative and positive. So we can write that it says in that order. So log 2 of x over log 4 of x is going to be equal to, right, this one, and this one is going to be equal to this one over this one. So log 4x over log 8 of 2x. So with problems like these, logs can be kind of tricky, but they behave a lot nicer when they're all in the same base, which here they aren't. And sometimes it's not really very easy to convert the logs to different bases, but here they're all powers of 2. So I think that gives you a hint that you're probably going to be able to convert them, relatively, maybe pretty easily, right? So let's, given that they're all powers of 2, let's convert them all to log of base 2, right? So we'll rewrite them. Log 2x, log 4x, and then log 8 of 2x. Now this one's obviously already in base 2, so let's convert this one to base 2. So we have log base 4x. So this is saying that if you have 4 and raise it to the power of log base 4 of x, that's going to equal x, right? This is pretty much the definition of what a logarithm is, right? It's an exponent that you slap it on the base and it equals, whatever's in the log. So we want this actually to be a 2, right? Because then we can write it as a log of base 2, right? If that base of the exponent was 2. So we can actually rewrite 4 as 2 squared. So we can say, instead of this, we can say 2 squared to the power of log. This, right, this doesn't change, because this parentheses can basically just be rewritten as 4, in which case this is the same. So we can just rewrite it like that. And then because of the properties of logarithms and how it works with putting, or properties of exponents and how it works with putting exponents on exponents in a tower, you can actually just multiply the log base 4x and the 2 going down. So you can actually just rewrite this as 2 to the power of 2 log 4x equals x. So now we have a base 2 like we want, so we can rewrite this as just a log. This whole expression is just one log, right? We can say log base 2 of x, right, equals 2 log 4x. And so we want to solve for log 4x because that's what we're trying to rewrite in the first place, right? So to get that by itself, divide by 2. So we have log 4x equals log 2x over 2, right, equals log 4x. So this is how we can rewrite it as a log of base 2. So I'm going to write that somewhere maybe, right here maybe, log 2x over 2. Okay, so now we just have to do the same thing here. It's pretty much the same process. You just rewrite it, 8 to the log 8 2x equals, it's 2x this time, right? Because we just want the thing that's inside the log. Again, change this to, instead of 2 to the second, just have 2 to the third, and this stays the same. 2x equals 2x. And then same trick as before, 3 log 8 2x, right? That as the exponent equals 2x. And now we rewrite the whole thing. All right, so these are pretty much the same thing. They just look a little bit different, but the 2x really doesn't change anything. So it's the same process for both the log base 8 of 2x and the log base 4 of x. Write this as log 2 of 2x equals 3 log 8 of 2x. Okay, so we want to solve for this, like before we did right here. So we divide by 3 on both sides, and clearly log 2 of 2x divided by 3 equals log 8 of 2x. Okay, so now we have this. So let's rewrite this as log base 2 of 2x over 3. Okay, so now that we have all three of them, right, in the form of a log of base 2, it'll be much easier. So let's rewrite this right here. Let's rewrite that. So it was so it was the 2x, actually that's going to be the same. So log 2x divided by this part. So instead of writing the log base 4 of x, we're going to write the log base 2 of x divided by 2. So we're going to have a fraction in a fraction here, but those aren't too tricky to deal with. Equals, and then the same thing here is just going to be here. Log base 2x over 2. And then it was log base 2, 2x over 3. So log 2, 2x over 3. So now let's rearrange this, right? So if we're dividing by a fraction, we're multiplying by the reciprocal. So this is going to be log 2x times 2 over log 2x. So this is obviously going to cancel out and just be 2. So this entire left side is actually just 2. So we have 2 equals, and then do the same thing here, divide by a fraction, multiply by the reciprocal, is going to be log 2x over 2 times 3 over log 2x, not just x, 2x. And because that 2x is not going to be able to cancel out the same as the other one, but still not too bad to deal with, right? So 2 equals 3 log 2x, a lot of writing in this one, over 2 log 2x. Okay, so now it's a lot easier to solve for x. So we want to get something where it's log 2 equals something, or log 2 of something equals log 2 of something, because then we can just set the inside of the logarithms equal to each other. For an example, it's kind of like when you do the whole, like, this is unrelated, this is just an example, like 2 to the power of like 4y plus 1 equals 2 to the power of like 2y plus 3, right? Since they're on the same exponent, you can actually just, or since they're on the same base, you can actually just set the exponents equal to each other, right? And it's kind of the same thing what we're doing here. So this is unrelated, this is just an example, but we kind of want the same thing to happen, where if we have log 2 of something equals log 2 of something else, a different something, then we can actually just set this equal to this. That's what we kind of want here. So let's, get rid of the denominator like you usually would. 4 log 2x equals 3 log 2x. Okay, so now it's helpful to use another one of those log properties, of which it's actually a lot, so you kind of have to remember those. But this one says that if you have an exponent inside the log, you can turn that into a coefficient outside the log. And also you can work in reverse. So we can change this coefficient here and this coefficient here into exponents in the log, right there, and then right there. So right, this is log base 2. So we're going to have 2x, well, I guess parentheses and parentheses here, but all of that to the 4th power. And get rid of that coefficient. And then we're going to do the same thing on this side, but we don't need the nested parentheses. The 3rd power. Okay, so now we have this equation, and we have, like I said before, we have a log 2 of something equals log 2 of something else. And so now we can just set the inside of the logs equal to each other. So 2x to the 4th equals x to the 3rd. Distribute that exponent. That would be 2 to the 4, x to the 4 equals x to the 3rd. So now divide both sides by x to the 3rd, right? At this point, it should be pretty doable. And you have 2 to the 4, x equals 1. So x equals 1 over 2 to the 4th. So x equals 1 over 16. So do we want x? Let's see, what did we want here in the original problem? We wanted m plus n, where m and n is x as a fraction. So we want, so m equals 1, n equals 16. So m plus n equals 17. And in this test, everything is expressed as a 3-digit number. So the answer is 017. Okay, so this one, I gotta admit, this is a trickier one. I think the main problem here is just one, remembering all the log properties because there's a lot of them and you can get them mixed up pretty easily and kind of start making up ones that don't even exist. So you gotta have those straight in your head. And then also this right here where we change the base on the logs, I think is probably another tricky part. This is the part that took me a while to get, just to get an understanding of it. But it's helpful to remember logs are exponents, so you can always rewrite them as the base to the log expression equals whatever's in the log expression. And here that definitely helped us out because we were able to rearrange it and then solve for it in base 2. So I think that's going to be it for this problem. Hopefully it wasn't too difficult if you were following along. And yeah, stay tuned for next week. Tell me what I did wrong this week. And thanks for watching. See ya.